We're super excited about this topic. We're going to be talking about how OpenDDS and artificial intelligence together are truly reinventing the mining industry and reducing environmental impact and helping Plotlogic grow their business in really incredible ways. So we're very honored to have the CEO of Plotlogic here with us, Andrew Job, and he'll introduce himself here in a moment. We also have Adam Nitz, who's the practice lead of the OpenDDS product team, and he's also a partner here at OCI. So as a participant, you are muted, but please, you've already found the chat box, so keep your questions and comments flowing. We'll do our best to address those as we go. We definitely want this to be conversational. You're also welcome to use that Q&A box. And so with that, I will hand it over to you, Andrew.
Yeah, g'day. So as Nikki said, I'm Andrew Job. I'm the CEO and founder of Plotlogic. So as I guess a bit of a quick introduction about myself outside of the specific topic tonight, I thought it'd be worthwhile just spending a moment telling you a little bit about my history and sort of how I got to be doing what I'm doing right now. So I actually come from a very strong mining industry background. I started in the mining industry back in 1998, did a degree in mining engineering, literally worked on the coal face for a number of years back, when coal was still a thing. And then sort of worked in a whole bunch of different commodities and essentially management type roles. Ended up becoming the general manager for a bunch of mines here in Australia for a large company called Anglo American. So I was looking after several large-scale mining sites, lots of equipment, lots of people, around about 1,200 people, and a $500 million a year sort of operating budget. So relatively large-scale mining operations. And one of the things that I guess I'd always been very passionate about in my time in the industry was about how we could do things more sustainably, more efficiently, and be able to deliver the natural resources that the world needs, but do it in a way that actually doesn't destroy the planet along the way. So it's something I've always wrestled with, and over many years of seeing how the industry works, I've seen some good pockets of where things have been done well, and other areas where I see some really significant gaps. So over a number of years, I got involved more in the automation and robotics space, and started talking with some people that were involved in essentially fully autonomous mining shovels. And then from there, identified a really significant opportunity about how we could combine AI and real-time robotics and advanced sensor technology to be able to make mines super efficient and sustainable. So reduce carbon footprint, reduce environmental footprint, at the same time make the mines more efficient, which then delivers more resources on a lower cost base and makes those mining operations more sustainable. So I've been really excited in this field for many years. Back in 2016 now, I made a decision to quit my job and do something which everyone considered to be pretty controversial at the time, and that was to go and basically form my own company, but at the same time start a PhD in this space. And I wanted to do the PhD really because I had this idea about how we could do things better, but really had nothing more than an idea. So I kind of thought it was time to put myself back through school, and started doing a PhD on essentially real-time machine guidance using hyperspectral imaging sensors, or at the particular time it was more focused around what any sort of sensor, not necessarily hyperspectral, but that's ultimately what we came at. So I did that for a while, and then essentially built a very early stage prototype system for doing some real-time precision grade control. That was done as a combination of my own work plus a collaboration with the University of Queensland and some industry partners that were able to help with some funding of it. We used OpenDDS even in the very early stages of the platform that we were building, for really three reasons. One was we were looking at real-time machine control as the end game. And so, having that ability to essentially provide that real-time publisher-subscriber model was super critical for us. Also, we wanted something that was really robust, really reliable. We knew was able to work essentially continuously or as continuously as the machines were operated. So we needed something that was truly tested and ability to be reliable. But also we knew that even at that point in time when we we're doing this early stage prototype stuff, that was all about how we could scale this, not just for one sensor on one system on one mine site, but how we could then potentially interconnect a whole bunch of sensors and provide real-time information flow across the entire complex mining business to guide machines, but also use it to guide decision making. So we chose OpenDDS right at that very infantile stage. Got some really good traction, and then after that, essentially from about a year or so ago, the company went from just being me and one other person to basically two other people that were essentially really deep in physics and the hardcore algorithmic element of what we're doing. And then over the last little period, we've then grown the team up to 25 people over the last essentially 6 or so months, and we're doubling again out to 50 over the next few months. So reasonably aggressive sort of growth scale, although we're still very much heavily focused on the deep tech side of things, so we're still technically pre-commercial, but we, as I said, gone from a few people to 25 over the last 6 months, and we'll go up to about 50 by the end of June this year, and then we'll look at growing again pretty quickly after that. And we've got some really good investors on board, so we're backed by a bunch of really top-class Silicon Valley firms that are really interested in helping us build this really cool deep tech business that can help deliver sustainable resources. And we've also got some really good early clients on board. So BHP, for those not familiar with the mining industry, is the world's biggest mining company. They're one of our early client partners and have been really good to work with. We've also got contracts with Anglo American, South 32, and some other companies as well. So we're building out a portfolio of relationships with some key partners there to help us make sure the technology that's being developed and implemented on mine sites is very sustainable and very usable, and it is exactly what mining guys want. So that's I guess a little about myself in a nutshell, and how I kind of fit into the scheme of OpenDDS and the company, and how it all sort of interweaves together.
Oh, thanks, Andrew. So to introduce myself, I'm Adam Mitz. As Nikki said, I'm with Object Computing, and I'm a principal software engineer and partner. We're talking about OpenDDS in particular today in this session, but Object Computing does a lot more than just OpenDDS. So we'll talk about some of those other parts as well as we get there. But just for some background, I've been with Object Computing for 16 or so years. I guess I've lost count at this point. I worked on many different kinds of software systems throughout that time, but with an emphasis on the systems and frameworks for real-time distributed software. So DDS being a big part of that. Our group within OCI, which is our shorthand for object computing, I should say, focuses on distributed real-time and embedded systems, and within that heavily focused on OpenDDS, as we're talking about here. So for those that may not be familiar with it, OpenDDS is an open source project. It was started within our company and still is maintained by us. And it is an open source and widely adopted standards-based real-time publish subscribe solution for distributed systems. OpenDDS implements the DDS specification. So the DDS itself is a spec that comes from the object management group, and there's a few different implementations around, but OpenDDS is a fully open source one that has been supported for the last 15 years or so by our company. So our mission is a few different things, but in general to develop and sustain OpenDDS as a completely open source project. And then as our practice, essentially what we do to make that part of our business is to help our clients make the most effective use of that, whether it's through consulting, custom development, training, all kinds of different sort of customized engagements to what the clients need to make them successful using OpenDDS and other open source software within the solutions to meet their business needs. So, Andrew, I think you may have touched on this a little bit in your introduction, but I'll put the question back to you in case you want to go into more depth. But why did you select OpenDDS as the connectivity framework used in your system, and what particular characteristics were you evaluating when you made that kind of decision?
Yeah, so I could probably start with the second bit first. We did have an evaluation framework that we put together before we went down the path of OpenDDS. More generally, we like the idea of open source, as much as possible, but that wasn't a key decision point for us. We wanted to get, the best, I guess, approach that we could possibly get. And then, it just happens that OpenDDS fitted those criteria perfectly. So, from our point of view, we're quite agnostic about open source, but really testament to you guys that you're putting the effort into maintaining that, because it's still very, very useful as a model. But the big things that we looked at was, when we started with this as an idea, even though it was quite a sort of nebular idea in some regards about where we're trying to take the technology, we always knew the end goal for the mining industry, and still is the end goal for the mining industry, is to have fully autonomous, remotely controlled operations where all the components essentially are interoperable in the sense that that we can have one component being able to provide information to another component and do that in a relatively autonomous fashion. So for us, interoperability was a key element of that. We already, when we started doing the work that we were doing, had some exposure with OpenDDS being used for real-time shovel control. So I was involved in a project many years ago now that was using OpenDDS as the publisher-subscriber model for a project which at the time was P&H to automate mining rope shovel. And so they were trying to autonomously operate the shovel and use that to load a truck. And that was already being used in that sort of that project. Also, Caterpillar, with some work with their semi-autonomous machine guidance, was also using a similar sort of model, and also using OpenDDS for part of that. So we knew that there was some really good capability in terms of being able to feed in off that existing body of work that had already been proven in a rugged mining environment. So that was a key element. The other key part is we really wanted, really super essential for us, that we could have a publisher subscriber model that was super, super fast, so that we could essentially get to complete real-time control guidance, or at least real-time information flow for what we're doing at the moment, and not have that as being an inhibitor in anything that we do. And we made that decision quite early on, thinking years down the track instead of months down the track. Some of our competitors are still wrestling with this exact challenge. So while we've been able to move quite quickly to essentially provide real-time models that can then talk to a pre-trained AI model to produce a result really, really quickly, our competitors who are looking at this from a traditional hyperspectral imaging approach, what they do is they collect a whole bunch of data statically, and then they'll process that, produce an image result, and then they might do something with it. But by that stage, it's in many cases hours, if not days later, before they can do it. And we're saying, no, that's not good enough for us. So the ability to do things really, really fast was super important. And even as recently as last night, one of our clients was talking to us about exactly this, because one of our competitors was basically still claiming that the stuff that we're doing can't be done because they've still got this paradigm of, oh no, well, you've got to collect this data, produce an image, and then you've got to process, and that takes hours. We're like, well, no, we've just changed the operating model completely. So that's really important for us to have that speed. The other thing is the model allows us to capture everything, every single sensor that's connected to the framework in a way that allows us to build these really, really perfect digital twins. So essentially, by logging all the data that flows over OpenDDS, we can then go back and we can replay any sensor that's performing and seeing if there's areas that we could have changed an algorithm with, which again is a really huge advantage for us. And I sort of touched on it up front in terms of like the ultimate vision for the business, but really, our goal is to scale not just across the mine site, but also up the stack, so to speak, in terms of interfacing into scheduling software, interfacing into decision support systems, dispatching systems, and the like, and then go across lots of different mine sites, within the same company or same commodity or the like. So the ability for us to have a foundation model that is very, very scalable, could work at massive scales, is really important for us. And also, tying in with that is the ability for the system to be very reliable. So we've proven this time and time again that it just works. Aside from if a developer introduces a bug, which we usually get to before it goes out in the field, but the system is actually really, really reliable. We know that it's just a very trustworthy, very robust system that when we turn the system on, we just know we can count on OpenDDS. So that was a big decision for us compared to some other models that we'd seen, and we're really, really happy with the decision, and we think that's given us a huge technical advantage over many of our competitors.
Excellent. Yeah, one part of that there's so many different pieces in there that we could dig into, but one part that I would just want to highlight that I've seen kind of time and time again when discussing different use cases, different ways OpenDDS can help build out a system of this sort, is that idea of like componentization and the interoperability, right? Of being able to build software modules that can be tested independently, can work just based on the pieces of the data they need. Usually we talk kind of in terms of like topics, because DDS likes to talk about topics. And when discussing this in our team and among colleagues, we've often thought about this parallel with the idea of microservices, which is a pretty common architecture these days in certain kinds of systems that aren't necessarily real-time publish and subscribe, but we see that kind of architectural similarity here, right? Where it's about building these components that can scale up, that can be tested in isolation, and that can really let you build robust and scalable systems, even having different teams of developers working in different parts concurrently, and knowing that it's all going to come together.
Yeah, and that's something that we've seen this already with even in the early stage of our business, in that because of the model that we've chosen, we can basically go from this idea of what our competitors are doing, saying we do hyperspectral imaging and then we do a whole bunch of processing with it. So no, we basically take sensor data from somewhere between 1 and n sensors, and we're using that to solve an industry challenge, which is how we get precise control of the ore body to feed into real-time systems. So we've been able to bring new people into the team, and one of the challenges that a lot of new teams faced is when you start scaling up, even within your developer team, people start tripping over each other because they're like, oh, I can't work on this because this goes in conflict with something else. We were able to bring in another 2 developers literally over the last couple of weeks, introduce them really quickly to the model about how you build a resource manager through the publisher subscriber model, and get those guys working essentially independent of each other, on a branch where they could do some stuff, test some things, and we know when it's working, we can then bring that back into the main line and add value to the system straight away. So even within the core sensor stack itself, this model works really, really well. And then of course, as we then go across different sensors across the mine site, it also allows us to just keep scaling really, really rapidly and prototyping in a way that doesn't destroy other parts of the business while we're trying to do it. So it's the model works really, really well for us to scale.
Right, and I think when we talk about scaling, it seems like we're talking about kind of a few different dimensions of it that are related to each other. The idea that, like, well, as your business scales up, you talked about your journey a little bit, starting at the startup and growing the company by huge amounts. There's that sort of scaling in terms of the team and the requirements that the software has to meet. I imagine those kind of scale too as you have new projects and new clients you're dealing with. And then we're also seeing scaling in terms of kind of the software view itself, right? The size of the input is going to get larger. The size of the machines you're running is going to, many more of them or more capacity. So I think those things kind of go together, right?
Absolutely, yeah. No, that's exactly the way that we look at it as well, and the OpenDDS model works really, really well for us in that regard.
So Nikki, I think I'm going to throw it back to you. Unless you wanted to add anything else there, Andrew, while we're getting Nikki.
No, I think that that covers it. Really encapsulates it quite well. I mean, as I said, from our perspective, that whole idea of OpenDDS allowing us to scale really quickly has been a huge advantage for us over our competition. Although Kat's probably out of the bag now with this presentation, but that's fine. We've had a pretty good run at it for a couple of years, so we've got a good head start. But certainly just being able to think about the requirements. And one thing, if people have jumped on this call to think about maybe using OpenDDS or some of the other object computing elements, the one thing I'd say purely from a requirements point of view is, we try to keep our use cases and requirements and our model, I guess, as closely, it sort of seems almost abstract, but as closely aligned to the vision for the business as we possibly could. And then said, okay, what models, what requirements give us, I guess, the most flexible solutions, but not flexible to the point of providing usefulness that we actually need. And so when we did that assessment for OpenDDS, we found that absolutely this was the right one for us, and couldn't have been happier with the decision that we made. And we know that a lot of the top robotics research groups for mining are also using OpenDDS, and also having some really good success there. And we know that companies like Caterpillar and Komatsu are also using OpenDDS in some of their models. So the ability for us to be able to sort of play nicely with that is a huge advantage for us as we scale up.
We love to hear these kinds of success stories, and it's so great to hear that you can rely on OpenDDS. We really do put a lot of pride into that. And so on that note, I was hoping we could switch gear to the team itself. And in particular, over the past several years, Adam, the team has been working on implementing some really interesting new capabilities around security and X types. So I was hoping you could talk to that, Adam.
Sure. Yeah, Nikki, I think your audio was breaking up a little bit. I don't know. I hope that wasn't just me. But
I'm sorry.
I think we heard. I'll repeat part of that, where you were asking about kind of where the evolution of OpenDDS itself has gone the past few years. So we have done, a number of things to kind of continue the evolution of OpenDDS as a product, looking at especially the other specifications that have come out of the object management group more recently. So for a little history on this, and I'll try not to go into too many details of specs that probably no one wants to get into, but we could kind of think of the DDS spec itself just defining this model and semantics behind how are we going to agree to do publish subscribe data distribution, right? What is a topic? What is a data writer? What's a data reader? How do the quality of service policies work? All those things about how we're going to exchange data across the system. And so that DDS spec was silent on a number of interesting things that have to happen to really deploy one of these systems in the real world like Andrew's doing. And so things like, well, how does the wire protocol work? That wasn't in the original DDS spec, that came later. So OpenDDS did implement that. It's called RTPS for short, but that's the standardized wire protocol for DDS. And then kind of following on from that, more recently, we've had things like the DDS security specification. So when DDS started, it was silent about how do we secure this data on the network, right? Certainly you could develop many different ways of securing the data on the network, and it could be down to your own decision about deployment, like maybe you're deploying it on an already secured virtual private network or whatever your solution would be. Now with DDS security, there's a DDS standard way of addressing authentication and access controls and encryption. And it kind of gives us a sort of a DDS native, if you will, way to address those kind of deployment concerns and say that we can now deploy even across the public internet without having a separate security solution like a encrypted tunnel sort of thing to deal with that. So that DDS security is one of those major features that have been added to OpenDDS in the recent years. And the other one, the newest, is X-types, which is the short name for a long spec name of the extensible dynamic topic types for DDS. So we just say X-types for short. And OpenDDS now has features from the X-type specification that really get into another part the original spec was fairly silent, or at least quiet about, which is you have to define a data type for each topic, right? But what happens when those types have to evolve, right? When your system has to change over time, and you might have a reader and writer communicating with each other that don't have the exact same schema, right? They don't have the exact same type definition. So how do we give the application, architects and developers the tools to make that work in ways that will meet their needs, right? That will allow kind of the evolution of a system where different components that are communicating can have different, essentially, versions of the schema, right? So you can do kind of a piece by piece upgrade. And sort of taken together, all of these things kind of fit this theme of just finding different applications that OpenDDS can fit, right? Different sorts of ways of using it, where we see things like the deploying across the internet, updating different components at different times when schemas change, those sorts of changes, and lots of others that I won't have time to get into here. But there's a lot going on, so I encourage people to check us out at opendds.org or on GitHub under Object Computing OpenDDS. So
Hey, Adam, is my audio better?
Sounds great.
Okay, good. So I wanted to also make sure before we run out of time this evening, I wanted to talk a little bit about connectivity. So we've talked about, of course, DDS as a connectivity solution, but I was also hoping we could spend some time to talk about how that integrates with cloud, and how does that feed into a client's AI strategy, and how does it complement what the cloud vendors are already doing in this space?
Okay, I think that was a question for me, right?
Yes, it was. I have so much to
Okay,
say since I couldn't talk before, so I just
yeah. So one part of this whole, and it kind of flows directly from what I was saying before, this idea of, well, where can you deploy a DDS system? We may have started by thinking that, well, you have a network that you control completely, whether it's in your lab or your factory floor. I don't know what the mining equivalent to that is. I'm not enough of a mining industry expert like Andrew is. But you can think of that as kind of starting with a closed system of some kind, right? And then extending to all kinds of different deployments. And one of the ones, to answer your question, Nikki, that we're doing a lot with these days is a deployment that's, we think of as kind of a edge to cloud sort of deployment, right? So edge being this term for stuff that's not in the cloud, for example, some kind of embedded device, and also communicating with the cloud. So OpenDDS, especially these more recent additions to it, was really designed to support this kind of use case where data can flow to the cloud when it needs to, but doesn't always have to. So whereas some systems come in with the idea that every single data point collected by the edge devices, let's just say if they're sensors for an example, right? Every single data point from that sensor is going to go up to your cloud system. Or if there's a control message, it's going to come back down from the cloud, even if it was initiated on the user's tablet that they're holding on Wi-Fi. So what we're doing with OpenDDS in the cloud is seeing that, yes, of course, the cloud is important to many, many deployment scenarios these days, but using a system that can extend, right, to be OpenDDS in the cloud and OpenDDS on the edge can be a really valuable tool for building these large scale distributed systems, especially with things like the security model, right? Because then you have kind of this common understanding of what an identity is, what access control, all those sorts of things to apply in both edge and cloud scenarios.
So Andrew, how are you applying this in your edge to cloud scenarios, if you don't mind sharing?
Yeah, so we're currently having that conversation within the team right now because some of the challenges that Adam highlighted, which have been addressed by what he just described in terms of security and X types, are exactly some of the challenges that we're beginning to face as we scale globally. So we've got some deployments coming up in we're currently in Australia, but we've got some deployments that are coming up in South America, Africa, as well as Russia. And we also have the challenge of, with our edge to cloud stuff, that we need to push data up to the cloud, but often we have really, really poor connectivity. So we don't, when our system's out deployed on a mine site, there's no mobile phone reception. Often there's no Wi-Fi in the areas that we're working over. We're sometimes dependent on satellite communication, sometimes dependent on sort of rover models, that type of thing. So we can't have a model where we constantly pushing data up. We tried that on one of our many iterations about 2 months ago, and it caused the whole thing to come crashing down really, really quickly. So we have to currently address that. It's one of our working challenges. What we're physically doing in the field right now is just a straight VPN. So we just, so that's how we're sort of working. And basically what we do is we're not automating that step of the process. We deploy all our algorithms to the edge. We run everything on the edge and using OpenDDS. And then periodically when we get connectivity, we physically checking connectivity at a low time when we've got bandwidth and we're not doing something physically in the field, set up a VPN, and then we push data up that way. So it's not we don't feel like that's a sustainable model for us, but it's kind of served the purpose. So it's really heartening to hear what Adam was talking about with the models that have been built into OpenDDS, because we feel like that would be the front runner for how we'd sort of step forward to the next phase of scale and growth for us.
Yeah, that scenario with not always available connectivity is a really interesting one. And if we just take it back to kind of some of the original architecture behind OpenDDS, it's really, if you look at it, it's about these caches, right? You're going to populate a local data writer cache, and then somewhere there's a data reader cache, and it gets populated by the network, right? The data flowing in. And so that idea that these two caches can get synchronized when possible, right? When the connectivity is there, right? But store data when needed is a really great match for that. So the quality of service and just those design principles behind OpenDDS really can work with that. And then we have to deal with all the networking stuff, right? Okay, how do we deal with getting around firewalls? How do we deal with fragmentation problems, security, all those other things? And OpenDDS has some answers for those. So it's all an interesting area for development.
And we run into this a lot, I think, especially as the world has gone more digital and contactless, particularly. It's like you can't necessarily rely on the cloud. You can't necessarily rely on 5G connectivity and when you need highly reliable applications. And so this is a really great strategy if you're thinking about exploring use cases in this way, thinking about how you could take advantage of these next generation solutions around connectivity and how that could potentially feed into your AI strategy. We'd love to talk to you. And if you have questions, we'd love to see those in the chat here. We'd love for you all to ask your questions. We've got 2 subject matter experts right here in the room with us. And
yeah,
so,
Nikki, maybe as we're waiting for questions to come in, if we are, let me kind of add one more thing on to maybe tie together some of these concepts you were just talking about. I think it was really interesting when earlier Andrew was talking about the way the system interacts with the AI model. And I'm not an AI expert, so I'll probably get some of the AI details wrong here, but I think AI and digital twin, right, things that are related concepts, come into the picture when we're talking about, having this real-time data collected in sensors or even monitoring data about, okay, how are the machines operating right now, right? You're generating lots of data, but being able to analyze that as much of it in real time as possible and not seeing it as a batch process that we're going to bring it all together and throw it up to the cloud and then tomorrow morning we'll see what happened, right? I think that's a really powerful use case as well.
Yeah, and it's something that we've been focusing really heavily on, and as I mentioned right up front, in terms of our selection criteria for OpenDDS, I probably didn't drop in enough about how our real-time ability is not just about collecting the data, but it's actually about collecting the data, converting it into information, and then processing and producing an output that's actually usable. So there's actually a whole bunch of steps to that for those not familiar with the specific domain of the sensors that we're using, the traditional way of doing that was exactly that batch model where you'd go out to a mine site, you'd have a couple of PhDs operating the sensor equipment, they'd scan an area like a mine face, then they'd collect all that data, they'd then run a whole bunch of pre-processing data cleaning algorithms to get it into a usable format so that they could then run a whole bunch of post-processing algorithms to convert it into to usable knowledge. And by the time all that's done, like it's maybe a couple of days later, that entire part of the mine's now been mined out, right? So it's completely useless to the miners. So, well, that was really nice to know, but we already mined that and it's already on a ship somewhere heading off, overseas. So, the ability for us to be able to have this model where we're constantly getting data. We've got so that's the DDS model. We've got pre-trained essentially AI models that are then ingesting that and just producing an output as quickly as it can receive that data. Works really, really well for us, and it allows us to do things that other people have not been able to do in the past. People have spoken about it conceptually, but never been able to sort of build the actual software framework that allows this to happen. Whereas we're very confident with the steps that we're taking forward down this path.
You mentioned very, very quickly, Andrew. When you say very quickly, what do you mean?
Yeah, so in sort of old school real time, it's like we want to have a result within 30 milliseconds. It's like video rate kind of stuff. We don't actually work to that. When we talk about real time or very quickly, for us it's sort of seconds, not hours. So the journey that we went on when we started the company several years ago, if we wanted to work out the grade of a piece of material that was then going onto being loaded by a shovel, put on a truck, to actually make that determination would take several days. One of our key first milestones was to get that down to a day to develop that, which was where OpenDDS initially came in, but we didn't have any of the post-processing stuff. We then got that down to an hour, and really the bottleneck was never OpenDDS, it was always on the post-processing, and now we're down to essentially seconds. And so when we say really quickly, what we're doing is we're scanning or collecting information about the material that's being mined as the machine is actually mining the material. And so within, say, a normal operating cycle for a shovel might take, say, 30, 40 seconds for it to pick up scoop up a block of material and dump it onto a truck. By the time that a truck's been loaded, we can tell you everything there is to know about that material on the truck, which, if we compare that against the existing approaches of doing it on mine sites, that's normally a 48-hour turnaround using traditional methods. So, and it's not as precise as what we get. So, it really does mean that for us, when we talk about real time, we're talking about the information or the knowledge that you require is available to you when you need it, without it or the information or the knowledge point being the bottleneck in terms of the process. So it's as the system's operating, as the mining system's operating, you've got trucks and machines flying around and moving material all around. As every time that machine needs to make a decision saying, where am I going to allocate this truck, or where do I go to next, the information is there for it to make a decision. So we're not the bottleneck in the process, so to speak.
One of the things that we hear from clients with similar use cases is that the cost is often prohibitive when you solely rely on the cloud for these types of processes and workloads. Have you been able to overcome that with OpenDDS or other solutions that you've implemented?
Yeah, so because of the way that OpenDDS works in combination with our pre-trained AI models, we're not paying for big compute. So we don't once we've trained a model for the processing side of things, we're not constantly paying for GPU or compute power in order to return it. So our models become really lightweight. Our onboard compute for our systems is actually really modest. It's essentially off-the-shelf technology. So we're not requiring a lot of brute force with compute because we have OpenDDS, which allows us to push the data through really, really quickly or essentially in real time. And then that is talking to our already pre-trained models, such as ingesting data, running some relatively lightweight model that then can produce an output quite quickly. So once we've actually got that running for our sensor system that's running on the edge, essentially it costs us nothing but a tiny little bit of electricity that we consume while we're running the computer. So it's there's no cost essentially associated with that. The only cost goes into the original training of the models, where we use our servers and that type of thing in order to build up those models.
That's helpful. Thank you. And I know the whole idea is autonomous mining, so there's no people. So this question might seem weird, but are there safety considerations? Are there life safety considerations in your implementation that you need to think about?
Yeah, so one of the reasons I went for OpenDDS is because we built off some previous work that some engineers had done, where they actually assessed real-time platforms for safety critical systems. And so, OpenDDS actually ticked the boxes. We work in heavy industry where, very large scale equipment, a lot of different forms of energy that can be very, very damaging. And safety is in the mining industry, rightly so, is the number one consideration. So we make sure that no one gets hurt. So so the safety element was important for us for OpenDDS, not so much on day one product when we were talking about the very elemental system, just collecting a whole bunch of data and doing something with it, but we were always focused on how we integrate that into a broader mining system, which means that this information needs to be reliable. And when we ultimately provide the sensing system to fully control a mining shovel, then that is a really safety critical system that can cause huge amounts of damage if the machine swings around and hits a truck or hits a person or whatever, goes into a direction that it's not supposed to go, or allocations of people and equipment are misguided because of the information that they're getting to drive their decisions. So certainly, safety is a really key element of our early thinking, knowing full well that into the future, that's something that is going to be front and center of the type of models that we're working with. So it was really important to bring that into our day zero thinking.
Okay, that helps. So we work with lots of different industrial sectors, and I'm thinking of a couple of clients in the transportation and railroad industry, and it's incredible to me how you wouldn't think it, but mining equipment and locomotives, these are just giant computers on wheels these days, and in many ways are some of the most forward-thinking industries in terms of technology, because they have to get the most creative in the ways that you've described, right? These traditional methods aren't always going to work in these types of settings where safety and the real-time quality of service is so critical. It's not just an inconvenience if the app doesn't work. It could truly be catastrophic in certain cases. Anything else you can share with us, Andrew, about what's next, what you're working on, what you're excited about?
Yeah, so we're scaling up the team again, and we'll grow up. Basically double the team over the next few months, and then probably do the same again in the back end of this year. We've used OpenDDS for our base technology that we're deploying, which is to scan mine faces, provide information really, really quickly. We're currently using that exact same model for real-time bucket by bucket grading on shovels. So it's super exciting that no one's ever been able to achieve this before, and we certainly right at the point end of the technology stick to be able to basically every single bucket of material that's being mined, be able to provide really accurate information, not just on grade but deleterious materials and other characteristics, which is super important for the mine to be efficient and sustainable. And we're using OpenDDS at the core of that. So we've got some deployments coming up in Russia and South America, where we're deploying essentially a shovel-mounted system to provide that real-time guidance. So we're super excited by that. We're actually also doing stuff on conveyor belts now as well. We're also using OpenDDS in our model, so we're seeing material flow over conveyor belts, then using our processing tool chain to be able to then evaluate the material as it's flowing into and out of the plant, so that we can provide additional guidance there. And we're also, on the thing that Adam spoke about, we're just starting the conversation around this model around, around security and the extensible types that we can then use to then feed, not just for those sensors to be able to provide information, but then up the stack, so to speak, so that we can actually be able to do real-time alerting and real-time scheduling using the frameworks that we built. So all the heavy thinking that we put into the business in the early years about the models that we're trying to build and what that would look like in in several years' time, it's now several years' time, and we're seeing the fruit of that come to the fore, and we're super excited about the next stage of our growth.
That's incredible. Thank you for sharing your journey and your story, and we love to be part of it with the OpenDDS product, and we'd love to be part of the future as well as we think about AI and cloud solutions and all of the things that can enable truly just incredible innovation happening at Plotlogic, and we really appreciate your time. I don't see any more questions in the chat, so we can probably wrap up, Adam, unless you have some closing thoughts.
Sure. Well, yeah, thank you again, Andrew. Thank you very much for your time and sharing all that great knowledge. I would like to encourage anyone who's listening to this, either live here today or in our recording, who wants to learn more about OpenDDS, to visit opendds.org. Look at the objectcomputing.com site under probably products OpenDDS, I would think. And especially if you'd like to get started writing OpenDDS programs, right? Writing some applications that do publish, subscribe, and learning how to do it, we do offer online training classes. So our introduction to OpenDDS is a fairly short class, 2 3-hour sessions. So 6 hours total of lecture and lab sessions. And so that can get you started writing software using OpenDDS. And then we have lots more from there. Other training, other consulting and development, and everything else around OpenDDS and similar distributed real-time and embedded systems.
Perfect. So we'll include links to all of those materials in our follow-up email, and this was recorded. We'll be sure to drop you a link. Thanks again, everyone, for joining. Thanks, Andrew. Incredible story. Keep going. Let us know how we're part of the vision in the future.
All right, lovely talking with you. Have a good evening.
Thank you very much.